A very good morning, girls. I hope you followed the previous class videos, and in the previous class videos we learned about the forward differences, and now here, of course, in the previous class I gave the information about the forward difference only. We don't have any application. A simple thing, just we have the only the table and how we have to take the values. We discussed that one only. And now here I am going to discuss backward. So backward differences. So in backward differences, simply write down the differences y1 minus y0, comma y2 minus y1, comma y3 minus y2, and so on yn. See here we are getting that yn and minus yn minus 1, right? Yn minus 1 are called first backward differences. First backward differences. If they are denoted by, actually we are denoting the forward with a del na, so here we have to take that the reverse. Reverse means simply like this. Okay, so now here del, and here it is nothing but backward operator. We don't have any name for this one, just backward operator. The first background differences, if they denoted with backward, opposite to delta, denoted by, this one is nothing but y1 del antam kada, opposite to del, otherwise reverse of del. Next, yeah, we can say that it is nothing but, of course, sometimes it is nothing but, it is also called as a del and a grad also. So now here I am taking that the reverse of that one. Now it is y2 backward of y3 and so on, backward difference of yn. Okay, so this is nothing but the denoting of the backward differences. Now respectively, right as it is, where this operator, where is called backward difference operator, where reverse of del is called backward difference operator. Similarly, we obtain so here backward y2. So we have that backward of y1, y2, y3 and so on. Now here we have that square y2. So what will be the formula? Simply backward y2 minus backward of y1. What will be the backward of y2? y2 minus y1 minus backward of y1, that is y1 minus y0. Now what we get? y2 minus y1 minus y1 minus y0. Now y2 minus 2y1 minus y0. This is second order backward differences. Okay. Now write similarly backward q y0 is equal to directly here y3. So already I gave that Pascal na 1 1 1 2 1 1 3 3 1. According to that one we have to now positive minus 3y2 plus 3y1 minus y0. Like this you have to. Okay, so this is the value of the third derivative of backward difference. Now put aside heading backward difference table. So in this table what we have to take now? Simply we have to take that x value y1. Next backward of y and square cube, and of course here I am taking that, otherwise simply you can denote with a general like this also, not y actually, del square, del cube, like that. Del ante ikkada ఏంటి రివర్స్, కొంచెం డిస్టెన్స్ లో తీసుకుంటున్నా. బ్యాక్వర్డ్ ఆపరేటర్, బ్యాక్వర్డ్ స్క్వేర్, backward cube, 4, 5, 6. Now here we have to take the values of the x. Now x0, x1, x2, x3, x4, x5, x6. Now y0, y1, y2, y3, y4, y5, y6. Next here backward means simply here we will denote in between. Backward of y0, backward of y1, y2, y3, this one we have to get, okay? y4, y5. Next one, square of y0, square y1. In the middle we have to write my every time, remember this one. Del square by 4. Next here cube we have. Cube means what we have to take? Del cube, backward cube y0, y1, y2, y3. Okay? So next here 4. Power 4 y0, y1, y2. Okay? Next y0, y1. Next finally y0 only. Okay? These are the values or table values, and of course if you get any doubt then simply you can take that. For example, ma'am in between me write ma confuse avutundi ante simply you can take that the values also as like here. Okay? So ఇప్పుడు ఇక్కడ ఉంది కదండి, సో దీనికి మిడిల్ లో అయినా తీసుకోండి, లేకపోతే y1 దగ్గర రాయండి, y2, y3, y4, y5, y6. నెక్స్ట్ వన్ ఇక్కడ ఫస్ట్ వన్ స్కిప్ చేయాలి. నెక్స్ట్ y1 దగ్గర డెల్ స్క్వేర్ బ్యాక్వర్డ్ స్క్వేర్ y0 కన్సిడర్ చేయాలి. ఓకే? నెక్స్ట్ పుట్ ఇస్ హెడింగ్ సెంట్రల్ డిఫరెన్సెస్. Central differences. So in central differences, write down now. The central difference operator is gamma. Is defined by the relations gamma of gamma by 1/2, which is equal to y1 minus y0. Right, as it is. So 1/2 is finished now. Next, don't write 2, 3. Gamma by 3/2 equal to y. Here yes, the value is y2 minus y1. Okay? So next 5/2, which is equal to y3 minus y2, and so on. Gamma of n, we can make it into y n minus 1/2. Here what is n? 1 minus 0/2. So here what we will get simply 1/2 directly we took. The next 3/2 means 2 minus 1/2, 4 minus 1. So see here now, 1 minus 0/2, actually it is nothing but 0, but here we have to take like a 1/2 formula, so that's why. Next 2 minus 1/2, 4 minus 1/2, which is nothing but 3/2. Like this we have to. Okay? So now n minus 1/2 is equal to yn minus 1. Then the central difference table x, y. Next value is gamma, gamma square, gamma cube, gamma power 4, gamma power 5 and gamma power 6. Central means middle, right? Of course, here I am taking that directly. Now listen, x0, x1, x2, x3, x4, x5 and x6. Now y0, y1, y2, y3, y4, y5, y6. Now gamma y 1 by 2, gamma y 3 by 2, gamma y 5 by 2, gamma y 7 by 2, gamma y 9 by 2, gamma y 11 by 2. Okay, so simply it is nothing but the value. Next here square. Square is different because here what you have to do is 1 by 2 na. Next 1 we have to consider here del by 1. Next here 1 and next here what we have to 1 is finished. Next del square by 1, del square by 2, del square by 3. Like this we have to. For squares you have to take like this, and for odd numbers, so then we have to take the ratio. Okay, so now here del square by 4, gamma square by 5. Next again middle cube we have, so now here gamma cube 1 by 2, gamma cube 3 by 2, gamma cube 5 by y 5 by 2, gamma cube y 7 by 2. Next power 4 now, so that's why gamma power 4 y1, gamma power 4 y2, middle, gamma power 4 y3. Next one gamma power 5 y 1 by 2, gamma power 5 y 3 by 2. Next here finally gamma power 6 by 1. So one is like a ratio, fraction, and one is direct value. Okay, like that you have to consider, and this is nothing but the central difference. And now write on here del y0 equal to backward y1 equal to gamma of y 1 by 2. అంటే ఈ ఫస్ట్ వాల్యూస్ అన్నీ కూడా ఈక్వల్. Similarly del cube y2 equal to backward cube y5 equal to gamma cube y 7 by 2. Okay, so next put a side heading symbolic relations and separation of symbols. Now write down. First put a side heading. Symbolic relations and separation of symbols means here we are going to discuss about some special operators. Okay, so now write down first one, shift operator. It is not related to your computer science subject, ma. So now write down. First of all, shift operator. Okay, so in shift operator, write down. The shift operator basically shifts the functional value yr, to the next higher value yr plus 1, and it is expressed as it is expressed as E y r equal to yr plus 1. Next value is nothing but ir plus 1. In general, simply e power n yr is equal to yr plus 1. In general, e power n yr is equal to y power, sorry, here it is 1 plus 1 n. ఇక్కడ 1 ఉంటే ఇక్కడ 1, 2 ఉంటే 2, 3 ఉంటే 3 అలా. Next, put a side heading averaging operator. Averaging operator. The averaging operator is denoted by mu. Is denoted by mu, and it is defined as mu yr. Yr means y1, y2, y3 and so on. Mu yr is equal to average now. Average means by 2 we have to get now, so that's why 1 by 2 of, write down now, y r plus 1 by 2 plus y r minus 1 by 2. Okay, this is the formula of the averaging operator. Just box it. Next, inverse operator. Right. It is denoted by E inverse, and it is defined as so generally here e power minus 1 now first value will be nothing but which is equal to e power minus 1 yr. Okay, is equal to, write down now as it is, y r minus 1. In generally e power minus n y r is equal to y r minus n. Box it. Okay, next write down. Here I said that separation of symbols now, so now here I am giving the, just write down the next point. The separation of symbols means separating the effect of capital E into powers of del, that is E is equal to 1 plus delta. You have to remember this one. E is equal to 1 plus delta. And what will be the delta value? It is nothing but E minus 1. You have to remember these two formulas also. E is equal to 1 plus delta. Okay. So this is nothing but the value, and if you want to know about the proof, then simply here we have the proof also. Now write down. We can prove the above result as follows. Now write down. The shift operator capital E is denoted, otherwise is defined as E of f of x is equal to E of f of x plus h. So generally ఏంటంటే ఒక function E of f of x అని consider చేస్తే that is equal to f of x plus h, and of course we know that the formula that is nothing but E y r is equal to y r plus 1 number. I gave this one. So E y r means here I am taking f of x, r plus 1 means some x plus h. So now we know that, write down, we know that del yr అంటే ఏంటి formula? Del yn. That means yn minus 1. So simply here, here we have that the formula for this del yr is nothing but yr plus 1 minus yr for the del. Okay, so now here what I am doing is here I have that the yr plus 1 value is nothing but EYR minus yr. Okay, now here del yr is equal to this one. Now del yr is equal to E minus 1 of yr. Now here yr get cancelled, then del is equal to E minus 1. Therefore, E is equal to 1 plus del. We prove the two results. Okay, this is nothing but the proof for the above result. Next, write on next question. Prove that backward difference is equal to 1 minus e power minus 1. Okay, now write down proof. We know that the first order backward difference is what is the formula? I gave backward yr is equal to, now you will get this one, yr minus 1. For the forward, r plus 1 minus r, and for the backward, firstly we will get yr, after that yr minus 1. Okay. Now here what I am doing is simply I am going to take that the value of the yr minus 1. Okay, now write down. We know that the inverse operator and e power minus 1 yr is equal to what I said, yr minus 1. Now substitute in above equation. Then what we get, backward yr is equal to yr minus e power minus 1 yr. Now backward difference of yr is equal to yr. I am taking yr common, 1 minus e inverse of yr. Now simply it is equal to backward equal to 1 minus e inverse. That's it. This is a proof. I am giving the proofs. You have to prepare all these also. Okay. Next question. Some more proofs. Ikkade proofs discuss cheste complete ayipotundi. That's why. Now write down. Next. Prove that gamma equal to, so nenu ikkada meeku easy ga gurtundadaniki I am writing the formulas. Del yr is equal to yr plus 1 minus yr. You can write this one. And ఇంకా ఏం నేర్చుకున్నాము ఇప్పుడు మనం EYR is equal to yr plus 1 and E is equal to 1 plus del. Next del is backward is equal to 1 minus E inverse. With formulas first one, second one, third, fourth, fifth one is backward yr is equal to yr minus 1 and sixth one is nothing but inverse operator yr equal to yr minus 1. Okay, so now here they are asking to prove that about a central. So now write down, prove that gamma equal to e power 1 by 2 minus e power minus 1 by 2. Actually E is nothing but a shift operator. Okay, now write down. We know that the central difference of order n, gamma by r and gamma square by r, gamma cube by r, all these are denoted with a definition, that is write down gamma of n minus 1, and here we have to take that y, okay, r plus 1 by 2. Okay, next minus, same thing, gamma of n minus 1 y r minus 1 by 2, because I gave the central difference formula with gamma of 1 by 2, gamma of 3 by 2 and so on. So now here we have that the formula is like this. Okay. Now what we have to do? We have to prove this result. Now what I am doing is I am taking that n is equal to 1 because I have that gamma only. Then what will get? Gamma by r equal to 1 minus 1. That means gamma power 0. So now here I am taking that as it is. Minus gamma power 0 by r minus 1 by 2. Now gamma by r is equal to any value power 0 is nothing but 1. So by r plus 1 by 2 minus y r minus 1 by 2. So now here what I have, simply I have that yr plus 1 by 2, yr minus 1 by 2. So already I gave that value of the EYR. Yr is nothing but r plus 1. So now here yr means r plus 1 by 2 I have. Now gamma yr equal to capital E. What I have to write? Yr. So I have to ignore this one. So now here what we get? We'll get power. Otherwise generally what I have, and from this e power n yr is equal to yr plus n. Now ఇక్కడ ఏంటండి r plus 1 లేదు. So general formula use చేస్తున్నా ఏంటి n. So from that e power n er is equal to yr plus n. Now ఇక్కడ ఏముంది r plus n. So then what we get? E power n, that means e power 1 by 2 by r minus, here also r minus 1 by 2, that means r plus of minus 1 by 2. Then what we get? E power minus 1 by 2 y minus 1 by 2. Now here we will get yr. Now gamma yr equal to e power 1 by 2 minus e power minus 1 by 2 of yr. Then gamma equal to e power 1 by 2 minus e power minus 1 by 2 is the required result. To prove this central, what we have to remember now? We have to remember this formula, and next just put n is equal to 1, then you will get the required result. Okay. Next write down. Next question. To prove that mu equal to mu equal to 1 by 2 of e power 1 by 2 plus e power minus 1 by 2. E power minus 1 by 2. Right. Here what is the mu? Mu is nothing but averaging operator. Now write down here mu is averaging operator, and we know that mu yr is equal to yr plus 1 by 2. The next average operator now, so plus yr minus 1 by 2. Okay. Now here what I have that again, simply it is in the form of yr plus 1 by 2. Then what we have to write? E power 1 by 2. Of course averaging operator means 1 by 2 of this one. Now 1 by 2 of same thing, e power n, e power 1 by 2 yr plus e power minus 1 by 2 yr. Now 1 by 2 of e power 1 by 2 plus e power minus 1 by 2 of yr. Now mu yr get cancelled. Mu is equal to 1 by 2 of e power 1 by 2 plus e power minus 1 by 2. Actually here the averaging operator mu yr is equal to half of the sum of these two. So simply here I use the formula of this shifting operator, and directly I have the result. Okay. Next prove mu square equal to 1 plus 1 plus 1 by 4 gamma square. it is nothing but mu square equal to 1 plus 1 by 4 of gamma square. We have to prove this result, and I will prove this result in the next class. Okay, I hope it is clear to you. And here in this class we discussed backward, central, just tables only. Okay, next we discussed the shifting operator, averaging operator, inverse operator. You have to remember these three definitions. And now here I am proving some results related to the operators. Okay, so in the next class we will continue with the next topics, and of course we will discuss few more applications related to this operators. Okay, thank you everyone.